Welcome back to the pizza delivery case. This is part 5, the last of the 5-part series in which we'll wrap up our case analysis. If you remember from part 4, we had done an analysis of current state data, both the quant data and a visual display of it, and identified that indeed we do have a business problem. Performance isn't just for a single pizza around 40 minutes. The mean is at 40 minutes, and to get performance to 28 minutes or less from earlier discussions. So in part 5, the learning objectives that I'd like to make sure that we go over include a quick review of the approaches that all process improvement methodologies follow, because whether it's DMAIC, Kaizen, PDCA, CQI, you name the methodology, they all follow similar approaches, and that's what we're following in the pizza case here. We'll take a look at using histograms to understand current state performance and consider the importance that variation and central tendency play on whatever future state solution we end up developing. And then finally, we'll wrap things up with a case by introducing what I like to call the shift and skinny approach towards process improvement. Let's reflect back on some of the work that we've done in the pizza case so far. I'm just going to flip over to another frame here for a moment and review this simple approach that I think all process improvement methodologies take. Again, it doesn't matter if you're taking a look at DMAIC, Kaizen, PDCA. These 5 steps are universally followed. And in step 1, we identify what the problem is that we're trying to resolve. What is the performance gap that we want to try to improve? So in the pizza case, we knew that the performance gap was, well, let me draw it out here. Okay, I've cleared up my frame just a little bit, so we've got a little bit of a drawing surface here. Let's take a look at what we've identified as being the problem statement. If you remember, we had a spec limit at 30. We had a pizza that was being delivered at 40 minutes, and we knew that it needed to get outside of this frown zone and inside of specification limits into the happy zone, and our analysis showed that 28 minutes is where we wanted to go to. In that situation, customer is happy receiving pizza on time, organization isn't having to give away free pizzas, and the organization, by making this type of a move, isn't having to overinvest in new technology, capital equipment to make it work. So in step 2 of all process improvement methodologies, we measure and investigate current state performance. This could be through collecting qualitative feedback, interviews, voice of customer interviews, direct observation, but it's also going to involve quantitative data analysis. And a large part of parts 2, 3, and 4 in this pizza case video series was about the measure and investigation of current state performance, and here's what we found. All right, and here's where we're at. What we've identified is that it wasn't just a single occurrence at 40 minutes, 1 in 10,000 event that had happened. The overall mean is 40 minutes. We've identified that the root cause for why the mean is at 40 minutes in part is related to the delivery drive time. It seemed to be the most impactful of the critical to quality variables. The concern is now if we develop solutions that only focus on moving the mean or the central tendency of 40 minutes to our sweet spot that we've identified earlier at 28 minutes, we run into a dilemma. If we take this curve at 40 minutes, this distribution at 40 minutes, and in future state develop solutions that shift the mean to 28 minutes like we have been talking about all along, there's a big concern I have if we shift that mean to 28 minutes and don't consider the amount of variation that is located in our distribution in current state. Let me show you what I mean. Let's zoom in here, and I've drawn current state condition. Mean is at 40. spec is at 30 minutes. Now in future state, if we only focus on moving central tendency, if we just shift this curve over to the 28-minute mark that we're looking at, here's the dilemma that I see. All right, here's what I've done. I've tried to draw our future state distribution by just shifting central tendency from 40 to the 28 that we had described earlier, right here. So mean has moved to 28 as the class and everybody has agreed upon earlier in the case. But if we don't take a look at the variation that is created in our current state condition, the fatness of our curve here, the amount of spread that we see in this curve, we're going to run into a problem. In our blue future state graph, let me explain. We'll change the color here. Everything below 30 minutes, as highlighted in green, is in the happy zone. It's meeting specification limits if we develop solutions that shift to 28 minutes. But the concern is that we do all of this work to shift performance to 28 minutes and ignore variation. All of this area in red is still going to be outside of spec. Free pizza is still being given away. Customers still dissatisfied. We've still got about a quarter, third quarter of all of our customers experiencing frustration. What we need to do is come up with another approach in future state that addresses the variation. Here's what I mean. And I know that for some individuals, the answer is, well, come on, let's just shift even more. Let's not stop at 28 minutes. Let's come up with a future state solution in which we shift to 20 or to 15 or to 10. Let's take a look at what happens then. All right, in this example, what I've done is I've shifted performance from 40 closer to, I guess when I eyeball it, around 15 minutes. You can see that now we've got a large amount of customers satisfied, only a small amount of dissatisfaction. This is an acceptable future state solution. But to get this large of a shift, we talked earlier about how a little shift can occur through traditional process improvement methodologies, reduction of waste, reduction of rework loops, reducing idle time handoffs, addressing variation. But if we want to increase that shift, move closer and closer to perfection, it's going to rely on a large outlay of technology, investment, capital equipment. And a little bit may be okay, but to get to the future state value that we need to move to 15, 10 minutes, it's going to involve an incredible amount of capital outlay, too costly for the organization. So instead of doing a only shift approach, a better solution for the pizza case is to take a look at the following. All right, in this next example, what I'm proposing is that future state performance address not only a shift in central tendency, moving the 40-minute mean to 28 minutes, but to also address the fatness of the curve here, the amount of spread, the amount of variation that's apparent in current state. So the solution in this next approach is what I like to call the shift and skinny approach. In the shift and skinny approach, what we'll do is develop solutions that do shift in future state performance to the 28-minute mark, but will also reduce that variation, and the curve will look something like this. Now in this version, average is at 28 minutes like we're looking for, but because we have created a solution set that addresses variation, a large amount of customers are satisfied. They're within the 30-minute specification limit. There's not perfection here. There's still some small amount that is outside of the specification range. But it did not require the huge investment in capital resources, the huge investment in new technology that our earlier solutions provided. Shift and skinny approach is an concept that is important for many process improvement initiatives, where you're taking a look at not just understanding where are you at in current state in terms of central tendency, the mean, but also where are you at in current state in terms of the amount of variation that you've got, and how do we build future state solutions that address both shift, central tendency, and skinny, the amount of variation and reduction of that variation. The goal of the pizza case is to introduce the shift and skinny approach.